topics for tomorrow's Regents exam, Regents exam, unit test. 2 weeks from tomorrow, by the way, they're your Regents. 2 weeks from tomorrow. Could be the algebra kids and have it 1 week from tomorrow. Okay, I don't know how much you want to ask right now. There are 3 multiple choice, but 2 of them are going to be from your Regents from last week. Okay, Regents from last week. Does it necessarily contain volume and surface area? No. Could be any of those multiple choices from last week. Okay, preferably ones we haven't done either. All right, so from last week's Regents exam. Formula's not on the formula sheet to remember. Anybody remember cone lateral area? Anybody remember cone lateral area going into tomorrow? Well, there is a circle attached to it, so I'm assuming it's something with pi, right? Pi. Oh, boy. RL. What's that RL? What's the R, radius, and the L for slant height? Please remember how the whole slant height thing works, especially with a cone and a pyramid. Is this my slant height I'm drawing in right now? That is the height, the altitude, Mission Impossible height. You have your radius, and then you have slant height right on the cone. And they form a right triangle, which you can do Pythag for if you want. How about cylinder lateral area? Pi dh, yep. Sphere surface area? 4 circles, 4 pi r squared. And then how about a hemisphere surface area? What do we always got to remember with the hemisphere? Surface area in particular. Just don't cut it. Just don't cut this in half and you're done. What do you have to add on to it? The circle. So we figured that out, that when you reduce and combine everything, it was 3 pi r squared. Why didn't I put cone surface area on here? Because what do you just do to the lateral area? Add on the what? The base. What do you do for a cylinder for surface area? Take your lateral area and add on two circles. Okay, so I'm not going to write that up here. What you did on Friday and what you did over the weekend, there's going to be one question on that. Surface area and volume ratios. And there's a loaded density question coming up at you tomorrow. Loaded. Change units, probably. Get ready. Change units. Convert. I'll give you the conversion if you need it, or it might be on your reference sheet. And then once you find volume, probably have to use density. Just like very similar. You guys remember the cone, snow cone example from the homework? Very similar to that one. How much is it going to cost me for X amount of cones? All right. Most of the time, a lot of people come in and say, hey, could you give me some extra questions on this? I just want to warn people, guys, I have given you every single density question I have except for the one I'm giving you tomorrow. Okay, in those 2 days of density work we did in your packet, I gave you everything I have. I have no more density questions for you to try out. Okay, can I print those ones off again for you? Like you've never seen them before? Sure, if you want that, that's fine, but I have no new density questions for you. I have given you in the 2 days of density we did, you have everything I have. Okay, everything I have. Is there anything you want to ask? Because we're not reviewing today. You can do that on your own. You'll see on the last page, I have given you, what is that, Lauren? Four questions, textbook questions to try at the top. The answers are on the following pages. You guys can try some of that out on your own later today or tonight. I want to do some Regents review, though, today. Is there anything you want to ask, though? Because I'll keep going unless you want to ask anything about going into tomorrow. Know the darn formulas. All right, know the darn formulas. All right, like I said, 2 weeks from tomorrow, we'll be taking the big Regents exam. We're going to go questions out of the June 2017 one, which you got today. I've selected a few of them. Particularly, I've selected ones where you guys start realizing what formulas you're going to need to know on your own, because it's been 40 weeks worth of stuff. You know, what formulas am I going to need that aren't going to be given to me? We're We're going to start with 25. Surprisingly, a volume one I start with Susan. Is this not 25? Okay, I'm in the wrong test then. All right, I got to give you a new one. That's why. We're in the August one first. That's why. Keep that one. We'll eventually work out of that one. Keep that one. Here you go. Keep that one. No big deal. You'll get all of them eventually. All the exams that have been out there. Over to the other two over there as well. There we go. Now we're good with 25. There we go. August 2017. Sue's saying that the volumes of both of those are equal. Is she correct? Explain why. Explain, so you got to write a couple sentences at the bottom. We can do this two ways. We can actually find the volume of both of them and figure it out, and then I'm going to do it a separate way. All right, so let's find the volume of both of them. Going into tomorrow's test here. Volume of a cylinder. Let's get this show started right. Volume of a cylinder, 27. Have your formula sheet. I believe. And there's one on every practice Regents I've been giving you. There's a formula sheet. So volume equals. Should be towards the back of your Regents. Okay. Pi r squared times the height. So for this one, what's my radius? 5 squared times the height. 11.5. And magically, when I go over here, we got pi 5 squared times the height of 11.5. And you guys will notice you don't even have to figure it out if you don't want to, because all the values are the same, correct? And you don't even, do you even need to show this work? No, you can just say the radius and the heights are the same, so therefore the volumes are the same. There's another concept I'm going to pull out right now, which we talked about for about 5 minutes, but never brought up again. Go ahead, Julia. Yeah, we went over this principle called Capillaries Principle, which said what? If the heights are the same, and anybody remember what else had to be the same? The cross-sectional area. If I cut this horizontally, what am I going to form? Circles, and are the area of the circles going to be the same? Yes, why? Because the radii are the same. Okay, so we could also say by Capillaries Principle, the heights, and I'm going to write this all out. So by Capillaries Principle, if the heights and cross-sectional areas are the same, the volumes will be the same. So I just wanted to do this one just to remind you of Capillaries Principle. So in 2 weeks, if it pops up, we never did this garbage. So a couple different ways you can go about it. A couple different ways. We good? Okay, I don't even know. I knew this was going to happen. What do you want me to give you? Because I have nothing to offer right now. I have literally nothing to offer. There's no chance that I am going to reduce Regents' homework. No. All right, deal. Deal. All right, here we go.
I think that's good.
Anybody else want to throw another one in before we vote? We're all good? Star. Ooh. Clock. Curtains. Fade. Genie. Ooh, okay. Cubes. Shatter. Flip. Slide. Page curl. Okay, flip. That's what I'm about to ask. Oh, let's go to the actual one then, so we're all in agreement here, because I don't want to. That's what I was talking about when it really wasn't. Let's see, view. Where's the page turn effects? There they are. All right, so let's see. Flip over. That's what we're talking about here. Okay, just let everyone know I'm putting it back on random, so there's no. Ready to go? So flip over. I got to see that again. Okay. Flip over Promethean Man. Here we go. Ooh, pinwheels, huh? Little pinwheels. Nobody brought that one up. Oh, there's the genie. All right, sorry. Bring your own donuts in. Okay, here we go. 31. Comes up every year. Got to be prepared for it. Find the center and radius of a circle that's not in circle equation yet. AKA, complete the darn square. Okay, complete the square to get it into the circle format. First thing I suggest is what? What do we need to get all together, and what's got to be on the other side? X is all grouped together, so x squared minus 6x. Y's grouped together, plus y squared. Move that 8y over. Plus 8y, and get the single number on the other side. Okay, time to complete the square twice. Once for the x's, once for the y's. Anybody want to give me an update? What's my new c value on the x's? And how do you get it? Saad, how'd you get 9? Because it's correct. Half your b value, half a -6, and then square it. That new c value should always be positive, remember. Always should be positive. Plus y squared plus 8y. What's my new c value on the y's? 16. The equation is unbalanced. Unbalanced. Why? Because you added what to the left side? 9 and 16. Hey, and this is a common mistake I've been seeing with you guys. That doesn't mean you move the 9 and the 16 over by subtracting. Whatever you added to the left, you're going to add to the right. You don't move those numbers over. They just stay there. Okay, now make it look like the circle equation. If you factored that, it would be the same two factors. What would they be? What was half your b value? Negative 3, x minus 3 squared, plus y, what was half your b value? Plus 4 squared, and then over here, 15, what do we got there? Ooh, perfect, literally, 81. Find the center. All right, what's the center according to this circle equation? 3, negative 4. Switch the signs. The radius is not 81. It's the square root of 81. 9 units. Every year, guaranteed. Yep, go ahead.
Like what unit? So we can like study this. What unit is this in?
Circles. It's in the circle unit. Yep, towards the end we did it. Okay, every year I've seen it on there. Every exam. Anything from you guys? All right, let's keep going. 2 genies in a row. Speaking of circles, our favorite unit of the year. Number 12. We got a tangent in PA and a secant in PBC. PB is 3 units. BC is 15. What's the length of good old PA? Woo. Anybody remember the saying we use with secants and tangent lengths? Blank times blank equals blank times blank. Jack? Yep. External, you were right. Don't embarrass yourself. External, good. Let's go whole tangent. That's usually the easiest. What's the whole tangent length? X and the external part is also x, so that's always x squared. Ooh, what about the whole secant now? Because it's not 15 times 3. Whole secant, 18 times its external part, 3. X. We sure? Whole, 15 plus 3 times external, 3. Oh, I thought you were questioning.
I thought you called number 3 first.
Oh, no. Easy, Rose, easy. No, I didn't call any numbers. I got you. Okay, take the square root. I've been trying to get you guys into this mode to help you guys out for next year in Algebra 2, breaking down a radical. Biggest perfect square that goes into 54. 9 times 6, square root of 9, 3, and then the radical 6 comes along for the ride. Questions? Little circle unit. Nice. Yeah, good times. Easy thing to do, let's just set them equal right away. No, not setting them equal right away. When are sine and cosine always equal? What do you got to know about their angles if they're always equal to each other? Madeline? Complementary. Yes, they are complementary. If sine and cosine are equal, that tells me their 2 angles have to be complementary. Meaning they add up to 90 or 180? 90, so 40 minus x, not equal to 3x, but plus 3x equals 90. Watch out for that trap. Okay, sine and cosine are equal, angles add to 90, co-functions. So what do I got here? 2x plus 40. $25. And you'll notice if you set, watch, hey, if you did set them equal to each other, which the Regents assumes you're going to, you get 4x equals 40, and look what answer's also there, huh? Just to suck you right in like you did a nice job. No, you didn't. No, you didn't. Oh, boy. Woo! A circle with a diameter of 32, area of the sector. Oh, boy. The measure of the angle of the sector in, wow. This is just a slap in the face. Area of a sector, and you better leave that answer in radians. Whew, panic time sets in Gym A. Changing my oh my boy, what's the formula? Change the calculator, panic just sets in, I'm just circling something. No, you're not. Don't change your calculator, there's no need to. There are one of two ways we can do this, and let's decide as a class right now. We either remember the formula that involves radians and sector, or we use the formula with degrees and convert it at the end. So I'm asking you guys. Do we just remember the formula with radians already in it? Or do we remember the degrees formula only and convert it at the end? Okay, so we're going to remember the sector formula with radians. I would know both. So let's go over both right now because they're not on the formula sheet. The sector formula in degrees and the sector formula in radians. Anybody remember the sector formula in degrees? Measure over 360. Pi d would be arc length formula. Sector's going inside the area. So don't use circumference, use the area formula, pi r squared. Pi d would be the arc length formula. So you could solve for the measure right now, convert it into radians if you're comfortable doing that. You guys are thinking arc length if you're thinking SOAR. You guys are thinking arc length if you're thinking S equals theta r. That's arc length in radians. I got you. You guys are getting enough exams for me, so I'm not going to give this to you yet, but I will eventually. It's a nice little packet of Regents exam facts you need to know down pat, and that formula is in there somewhere. Okay, so it's like a 5-page comprehensive review of the entire year, and that formula, yep, 1/2 r squared theta. That's in there. Okay, so I'll give that to you eventually. All right, so here now that we know it now, right? We know it. And now we can plug in here. So the area of the sector, everyone ready? 512 pi over 3 equals 1/2. What's the radius of this circle? Not 32. 16 squared. And the theta is going to be my angle in radians. All right, let's help you with the algebra here. 512 pi over 3 equals 1/2 of 16 squared. Make sure you don't do 8 squared. It's got to do this exponents first. And we're looking at 128 theta. Everyone good so far? How are you going to get theta by itself now? Divide both sides by 128. Guys, take a quick peek at the multiple choices. What do all the multiple choices have in them? They're all in terms of pi, right? So when you divide this now with your fraction template, strongly recommend keeping pi out of there because all your answers are in terms of pi, so keep it out of there. So get a fraction template right now. 512 over 3 on the first one. Probably have to do 2 fraction templates, one full one and then one in the numerator, divided by 128. Oh, beautiful. Keep the pi out of there. And what's this angle in radians? 4 pi over 3. Yes. So I would put, what I would do with yours, I don't know, do you have a fraction template or no? 512 over 3 in parentheses maybe? You could do, divided by 128, and then you could do, change it back to a fraction. You guys are all good. 1 1/3. That's 1 1/3, which 4/3 is 1 1/3. So even if you did 1 1/3, you could leave it like that if it was a free response, but you just have to notice that 1 1/3. Yep. Okay.